Hello again. For this question we have to determine under which conditions placed on x this sequence converges. Well, this is a geometric sequence because you can see it goes to the power n, and so as n goes up 1, 2, 3, 4 we just get powers going up, so our common ratio r is this expression here, 1 over x squared minus 1, brackets around that, in a geometric sequence. Now the condition for convergence is that we have to have, so it converges if the absolute value of that, 1 over x squared minus 1, is less than 1, or if it equals to plus 1. If it's less than 1 it'll converge to 0, or if it equals plus 1 it'll converge to 1, just be 1. Okay, so we've got those two things, so we just have to solve this equation, this inequality, or the plus 1, and away we go. Let's do that. So we've got to solve this, 1 over x squared minus 1 is less than 1. So 1 over x squared then minus 1 must be less than 1 or bigger than minus 1. And we'll just do both of those things to see what happens. I'm looking at the right hand side here. I get 1 over x squared minus 1. Oops. I'll add 1 to both sides of that inequality. We get 1 over x squared is less than 2. And if we now just invert both sides, you get x squared over 1. When you invert, you must change the sign of your inequality. We're now bigger than half, just inverted both sides, and then we'll take the square root of both sides, so you will get that the absolute value of x must be bigger than 1 over root 2. In other words, x is either bigger than 1 over root 2 or x is less than negative 1 over root 2. Okay, so there's our two things there. Now let's just look at the left hand side of this inequality. So we've got, just write it all out, we've got minus 1 is less than 1 over x squared minus 1. Well, if I add 1 to both sides of that, I get 1 over x squared is bigger than 0, which is always true, because when you square a number you always get a positive, so it's always bigger than 0. The only thing that we can't allow here is x equal to 0, so for this x is just any real number but not 0. So our condition then, we can do this and this. This is going to give us our condition. Okay, let's, with all of these, I recommend you draw a picture just so you really know for sure what's going on. So let's just draw a quick picture of y equals 1 over x squared minus 1. Just a truncus, and so we'll just do this. It's been gone down 1, so ugly truncus, but you'll get the idea. Here's the line y equals minus 1. Truncus that's just been moved down 1. Here's the line y equals 1. And for the absolute value of this function to be less than 1, it must be between these two lines, line 1 y equals 1 and y equals minus 1. Now, must remember to include, we can have it equal to plus 1 because then it will converge to 1. So those 2 points can be included, and everything, okay, we'll find the corresponding x value there and the corresponding x value there. And that will be, from our little calculations over here, that'll be 1 over root 2 and minus 1 over root 2, so that's 1 over root 2 and that's minus 1 over root 2. And we just need to go either to the right of that, or it's bigger than that, or to the left of that, which is less than that, for our conditions. So, and the 0, of course we cannot have that because it's the function is not defined there anyway. Right, there is our condition. If we want to write that with rational denominators, we should write it like this: x is bigger than root 2 over 2, or we have x is less than negative root 2 over 2. And the sequence converges. Oh, no, I've forgotten. I've got to include where it equals 1, which is up here, so I must have equals sign there. It can be equal to those, and that is because we must also include where it's equal to